The science of skin tone. Why people in mountains have fairer complexions. Forget everything you think you know about skin color and geography. While sunlight usually darkens skin, there's one place where the story flips: the mountains. Here, many populations have unusually fair complexions, and it's not because they avoid the sun. Today, we're diving into the Alpine Paradox, the surprising link between altitude and skin tone, and how evolution, biochemistry, and oxygen stress shaped these adaptations. Look closely at human populations living at high altitudes, from the Himalayas to the Alps, and you'll notice something fascinating. Fairer skin tones appear more often than you'd expect for people living so close to the sun. How is this possible? And why would nature favor lighter skin where UV radiation is actually stronger? The higher you go, the thinner the atmosphere becomes. And thinner air means less filtering of UV radiation. Every 1,000 meters of elevation increases UV exposure by about 10 to 12%. Add snow, which reflects up to 80% of UV rays, and mountain dwellers are bombarded with more UV than most people ever experience. So the question becomes, if UV is so strong at high altitude, why don't mountain populations consistently evolve darker skin? Here's the twist. Skin pigmentation isn't just about UV protection. It's about vitamin D. Melanin, the pigment that darkens skin, is like a built-in sunscreen. But it also reduces the skin's ability to make vitamin D, which is crucial for bone development, immunity, and reproductive success. In cold, cloudy, high-altitude environments, where sunlight is strong but direct sun exposure is inconsistent, evolution faces a trade-off. And for many populations, lighter skin was the winning adaptation, allowing enough UV penetration to produce adequate vitamin D despite harsh climates. Altitude isn't just about sunlight, it's about oxygen. High mountain environments come with chronic hypoxia, or low oxygen levels, and this affects everything from blood chemistry to cell metabolism. Some researchers propose that hypoxia-related genes may indirectly influence pigmentation by altering how cells respond to stress. Populations like Tibetans, Sherpas, and Andean Highlanders show unique mutations that help their bodies thrive in low-oxygen environments. And some of these gene clusters overlap with pathways associated with skin biology. It's not a single adaptation, it's a symphony of survival. The common belief is, strong sun equals darker skin. But human evolution is never that simple. Yes, people near the equator evolved darker skin for UV protection. But in mountains, evolution had to balance strong UV, cold climate, nutritional limits, cloud cover, and oxygen stress, all at once. Fairer skin in the mountains is not a contradiction. It's an adaptation to a complex challenge. Skin tone is one of humanity's most visible traits, but also one of the most misunderstood. It doesn't reflect intelligence, beauty, value, or identity. It reflects biology, history, migration, and thousands of years of adaptation. From equatorial deserts to icy mountains, humans evolved beautifully unique traits that helped them survive their environments. So the next time someone oversimplifies human differences, remember, skin tone is not just about sun, it's about altitude, climate, genes, oxygen, and the remarkable adaptability of the human body. Science reveals diversity, not as a dividing line, but as a celebration of how our species has survived everywhere on Earth. If you found this mind-blowing, hit like, subscribe, and tell me in the comments, which adaptation should we explore next?